Okay, let's get started. So I uploaded a sample midterm. So this one is just to get you an idea of the difficulty and length of questions that I probably am going to ask on the actual midterm. So it says sample right here. Are these questions going to appear on the midterm? No, so, and do you think I'm just gonna change a few numbers here and there so it's a different question? You hope so. Yeah, no. But the difficulty should be about the same. It's just that there are 4 questions here because I couldn't come up with 5 good questions. So there are 4 here. The actual midterm has 5, just so that you're aware. Has anyone done this or has questions about it?
What was it that you were, in the first question it says that the program takes as input 4 integers.
Mm-hmm.
Are you asking that you want us to come up with a program that like outputs the max? What do you mean by the maximum of ABC?
So let's back up. Let's look at this question. It says, write a complete C++ program. So what does complete C++ program mean? Yeah, include stuff, and then using namespace std if you want to use it, and then what? Int main, and then stuff in main. Okay, that says, that takes as input 4 integers A, B, C, D. What does that mean? Yeah, so I create int a, comma b, comma c, comma d, and then next line c in a, then c in b, c in d, c in d. It says, and then prints the maximum of these. What does that mean? So let's actually, yes. So let's just say that A is, I don't know, 5, B is 42, C is 1337, and D is 314159. So if these are the 4 values that I enter, which one am I going to print? Yeah, I'm going to print D. Why? That's the highest value. So how would I, at a high level, how would I write code to do that? Yeah.
You start with include IO streams.
No. Ignore all of that stuff. So include IOStream, we got all that. How would I actually do the maximum after I input the 4 integers? So I've seen the A, B, C, D part. How do I find the maximum of the 4? Yeah, if else statements. So at a high level, what would you do? You don't have to tell me the details, but what would you do?
So I can see if A is greater than B, or...
Yeah, but think about that for a second. How many possible ways can I order these 4 things, these 4 integers? Well, we talked about factorial before, and it happens to be 4 factorial, which is 24. Do you think I'm going to ask you to write 24 if statements? I mean, you can, but it's a waste of your time to do so. In fact, all of the questions on the actual midterm and this one, I think every single one has around 10 lines of code or less, every single question. Maybe 15, but they're not long questions. So what do you think is a better way?
You just need 4 if else.
Yeah, 4 if else. How would I do that?
So if A is bigger than max, then...
Oh, okay, so you said if A is bigger than max, so I need to declare an integer max too. So what should I initially give that a value of? Well, what if I give it value 0, what if all 4 of these are negative? Right? So what is a better one? So the high level idea is, so we declare a max to be something, and then if A is bigger than the maximum so far, then we're going to make the maximum equal to A, because we found out A is bigger than max. So A is the biggest value we've seen so far. And then what do we do after that? what if now we need to check with B? Because it may turn out, okay, A is big, but B is even bigger, hence B. So then we need to do B. Then what about C? Yeah, I need to do C as well. C is bigger than max. Max is C. Then I need to do D. Oh, and then at the end, I just need to C out max. Because one of those four is the maximum, right? So I will make an assignment at some point. But what should I set an initial value of max to? Well, if I set it to 1, what if all four of these are less than 1? Oh, okay. So am I wrong if I just pick A to be one of the values? Is that wrong? Well, if A is not the maximum, then one of these if statements will be true at some later point. Well, if A is the maximum, then I set it to be the maximum and I don't encounter any if statement. But I just set it to be the maximum value. So in fact, that's all I need to do. Well, look at this if statement now. It's redundant. Is this condition ever going to be true? No, it's never going to be true because I set it equal to A. So I can in fact delete that if statement. And that's all the code I need to do. In addition to the int main and the using namespace, whatever, all that stuff too. But the point here is coming up with a solution like this. I could do this and say, if A is less than B and B is less than C and C is less than D, or A is less than B and B is larger than C and C is larger than A, that doesn't seem fun, does it? So it's not a lot of code here, but it's thinking about how would you attack this problem, okay? So it's even writing like a potential idea in English is worth far more than just writing gibberish code that doesn't actually do anything, okay? So it's the ideas that count, not the accuracy necessarily of the solution, yeah.
So if they were to ask you to find, like, sort it from largest to small, then you'd have to do the long.
Yeah, so if I instead asked you, okay, I input these four values, then print them in, let's just say, ascending order, then that would be a little more difficult. So one idea that you might try is to find the minimum of these four, and then print that one first, and then try to find the minimum of the other three. But you're right, it seems like that one would be a lot more difficult. So, and that you would need a lot more code. So as I said before, the midterm doesn't, and the sample, does not have any long questions. None of them require a lot of writing, but they require thinking. So don't worry about, if you're writing lots and lots and lots and lots of code, you're probably thinking too hard, or you're missing the point of the question. Any other questions about this question? Yeah.
Just clarify, if you did if statements with like ands, with like A greater than B, or A greater than C and stuff, would that be wrong? Or would you...
It's not wrong, it's just that you'll be writing 24 if statements. And since there are 5 questions and you have 50 minutes for the whole test, how long do you have per question about? 10 minutes. Do you think you're going to be writing 24 if statements in 10 minutes? Probably not. So it's not going to be a lot of writing. Say that again. Any other questions about this one? Any other questions about the rest of it? Has anyone looked at the rest of it? Okay, one person has. So what should you do after this class? Yeah, look at the rest of it. And if you don't understand something, then what should you do? Ask questions. Okay. Okay. So I wasn't able to get assignment 4 out to you. So the assignment's written, but I don't have the test cases yet. So I didn't think it'd be a good idea to upload it and put the without test cases. I hear I'm going to get the test cases by Wednesday. And for that reason, I'm probably going to push the deadline of assignment 4 back a little bit because it's not an easy assignment. So I'm going to go over it just so that you get a heads up over it. So this is actually related to one of the research questions that I'm looking into right now. So it's looking at something called a Latin square. So a Latin square is basically just an n by n set of numbers like this. So this one is 4 by 4, 4 rows and 4 columns. And what you require is that every column doesn't have a duplicate and every row doesn't have a duplicate entry. So if you look at each one of these rows, there's no duplicate. There are 4 different values in there and the same thing for the columns. And so that's a Latin square. If you have 2 Latin squares, we can say that they are mutually orthogonal if you do the following. So here are 2 Latin squares right here, and you can verify pretty easily that they are Latin. And so what you do is you take these two squares and you put one over top of the other. So you superimpose them. So here's the result of superimposing them. So each one of these entries right here is composed of 2 digits. The first one comes from the corresponding entry in the first square. So you can see that this one is 0, 0, meaning that the top left of the first is 0 and the top left of the right one is also 0. Here's 3 and 3 across, 1 on the first, then 2, 2, then 1, and then all the way through the rest of them. And we say that they are mutually orthogonal if this 4 by 4 square right here doesn't have a duplicate anywhere. Okay? So if you look at here, how many entries are there in total? If there's 4 by 4? 16. So if I see 16 different entries there, then they are mutually orthogonal. The 2 original squares were orthogonal. And you can actually verify it by looking at this, but if you think about it for a second, each one of these digits you can think of as written in base 4. So it can be either a 0, 1, 2, or 3. If you convert it back to decimal, then there should be 16 different values. And here's the result if you convert them back to decimal. So if you look here, you say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11's here, 12, 13, and 14, and 15. So I do see 16 different values there. There's no duplicate. So therefore, we can say that these 2 squares up here are mutually orthogonal. So the question of whether, if you have a bunch of Latin squares, whether each pair of them is orthogonal, that's a research level question. So I'm definitely assigning it for your assignment. But yeah, so that's way out of reach. So what I'm asking you to do here is I'm going to have the user input these 2 Latin squares and, I'm going to have them input a bunch of values. You got to first off figure out, okay, are the 2 squares that were inputted themselves Latin squares? And if they both are Latin squares, then you have to figure out, are they in fact mutually orthogonal? If I superimpose them, do they give 16 different values? So you only have to worry about order 4 Latin squares. So 4 by 4. You don't have to worry about any other ones. So the user is going to enter 32 values, which are 16 for the first square, 16 for the second square. And you got to print whether or not the 2 squares are mutually orthogonal. So first off, whether they're Latin, and second off, whether they are mutually orthogonal. So that's basically the gist of the assignment. If you try to do this in a brute force way, you're going to be writing hundreds of if statements. So that's way out of reach in my opinion. So this is an assignment where you have to think first, and it says it in here to do this, think first about how you're going to approach the problem first. So first off, it says in here, but what is the order in which the values are going to be entered? Are they going to be entered across both rows, or is it one row at a time? Or is it columns at a time? You got to think about that. But even more importantly, think about what it means for a square to be orthogonal. So let's look at this first one. So what has to be true of these first 4 entries? They have to all be different. Is there, how many possible ways can I order these 4 values? 24, because they're 4 factorial. How many pairs would I need to check to see that there's no duplicate among these 4? Well, I got to check the first 2, first and the third, first and the fourth, second and the third, second and the fourth, and third and the fourth. That's 6 different if statements. You have to write each row or each column. Is there a better way? What's that? Well, I don't really care about the mode here because there's, yeah, I guess you could do that, but it's just that you're going to be saving these to variables, and it's kind of hard to work with that. But what else has to be true of these 4 values? If there are 4 different values, is there something that is the same no matter what order I place them? If I move like the 1 over here and switch it with the 3, is there something that is unchanging about that row? What about the sum of the entries? Well, what is the sum of 0, 1, 2, and 3? 6. So if the sum is 6, then do we know necessarily that there are 4 distinct values there? Not necessarily. If we insist that the user never enter anything of at least 4 or negative, so that they only enter things between 0 and 3, is there any way that those 4 things could have a duplicate if the sum is 6? So if I enter only 0, 1, 2, and 3, those are the only things I could enter. I enter 4 values, and the sum is 6. Could there be another way? Oh, okay, I see.
Well, the thought that I had to do it was just checking equality for all. You can do all that in one statement.
Yeah, okay, I see what you mean, yeah. I suppose you could enter 0, 2, 2, 2, but yeah, so one approach that I think might be useful is you have 4 flag variables that are initially set to false. If the user enters 0 anytime for this row, then set the flag variable for 0 to be true. And then if they enter 3 at some point, set the flag variable for 3 to be true. Same for 1 and same for 2. If all 4 flag variables are set, then you can't possibly have a duplicate. So you have to think about it first before you start programming it, because you may get knee deep into the problem and realize, oh, this is going to be a lot of work. I need to start over. So think about it first before you do anything else. Think about this one. So when I superimpose these, what values have to show up in here? Yeah, different ones. So if I have 16 different values, that would be a good idea to use. So another idea that you might try is there's a structure, and I'm not going to name it. I want you to figure it out for yourself. There's a structure in C++ that you can use that can hold a number of values that are not duplicates. So if I add a value and it's already in the structure, then the structure doesn't change. But if I add something that is different that wasn't there, then it adds it to the structure. So using that is potentially okay if you cite your sources, of course. So think about the problem first before you actually start programming it. But any questions at a high level about the assignment? As I said, I might push the deadline back because I haven't gotten the test cases yet. Okay, so let's talk about other stuff. So last time, what did we do last time? Almost finished loops, but what did we talk about with respect to loops? What, sorry? Yeah, if we talked about for loops, what else did we talk about? Two other main things. Do while loops, and what else did we talk about? We haven't really gotten there. What was the slide that I'm looking at right now? Sentinel. So what is a Sentinel? Yeah, right. So we don't know necessarily how many times the user is going to be entering stuff, but if they enter something that's like a stoppage value or something like that, or an invalid value, then I know to exit. So it's just a flag essentially to say we're done entering input. So in this case, if they enter -1, we can assume that they don't have anything else to input, so we're all done there. What is a do while loop in comparison to a while loop? What's the main difference?
Tests afterwards.
Right. So effectively, the while loop tests at the top, do while tests at the bottom. That's the main difference between the two. So effectively, while loops could be executed 0 times, whereas do while loops can't. Although I really shouldn't say that. I should say that a do while loop has to enter the loop body at some point, because we're going to be talking about something that allows you to get out of loops anyway. But it has to enter the loop body for sure. Yeah, so do while, effectively, other than that reason, it behaves exactly the same. So do while is good for menu-driven programs because you want to display the menu at least once. For loops, so when are for loops usually used? What is the main purpose of using a for loop? Yeah, so it's mainly used for either when you have a counter that's controlling the loop, or you know in advance how many times the loop's going to actually execute. So as an example, if we know that this loop's going to be executed exactly 5 times, then a for loop is a more suitable option. But could I use a while loop for this? The one right here? Yeah, why? Why am I justified in saying that?
The count limit inside the body.
I could set the count limit, but what was the more general thing that we showed last time? Right, so we showed equivalence between for loops and while loops. So there's nothing that a for loop can do that a while loop can't do, and vice versa. But it's mainly about which one is easier to use and which one's more appropriate. In this case, I would use a for loop, but I could use a while loop if I wanted to. Like this one, I know that I don't know necessarily how many times the loop is going to execute exactly, but I have another use of for loops is when you have a condition, a definite condition like this, and you have something to update at every point. So effectively, you kind of know how many times the loops will execute, but not maybe exactly the number. Yeah, so for loops behave like while loops in pretty much every other way. You can have some modifications here. These are not really that important. Yeah, you can omit some of the parts of it, but that's usually not the right idea. So which loop to use? While loop tests at the top, do while tests at the bottom. For loop is tested also at the top, but usually for when you have some updates to do. When while loops sometimes don't have that. Okay, so we ended up here last time. So we talked. I talked briefly about these nested loop things, and I said that in my research I have a 6 nestly deep loop. So these are actually kind of important. So a nested loop is when you have a loop inside of another. That's all they are. So what happens here is we enter this first for loop right here. Then we're going to immediately do all 3 iterations of this inner for loop for the columns here. And then we're going to exit the inner for loop right here and then come back up to the second iteration of the outer one. So if we actually copy this, I'm actually going to steal this code right here. Yeah, I'm going to steal this code. And then, come on, let me copy. All right, let's do this. So let's have int row call, and then copy this in. Forgive the formatting. Let's just call this nested for. So let's G++ our nested for loop. And then let's just see what actually happens. So let's look at the, let's look at the output. So it says the first three outputs right here. The first three outputs here are 1, 2, and 3. So let's think about this. So I said that the outer loop comes in first, and then we eventually come into the inner loop. So at the first iteration of this inner one, what are the values of row and call? They're the first iteration. They're both 1 because this is still the first iteration of the outer loop, and now we're now on the first iteration of the inner one. So they're both 1. So that's why the first output here is 1. Second iteration of which loop? So the inner one has to execute all of its iterations first before the outer loop can do another iteration of its loop. So here, row is going to be what value for the second iteration of this one? It is still 1. So, and call now is going to be what? It's going to be 2. So 1 times 2 is, I know it's early, 2. So that's why we see 2 here. Next iteration of the inner loop has call become 3. So, and row is still at 1. 1 times 3 is 3. So that's why I see 3 here. Next iteration, what happens to this inner for loop? It exits. Why? Because call has gone above the maximum value of 3. So this condition is no longer true. This loop exits. So this loop exits. There's nothing else in the outer loop body. So what happens to the outer loop now? It comes back to the top because now it needs to do its update and the check again. So row becomes what now? 2. So row is 2. Now we come to the inner loop again. What is the value of call now? It is assigned to 1. So call now is 1, but row is 2. Okay? So what is 2 times 1? 2. Yeah, it's not 3. 2. So next iteration of the inner loop becomes for what for call? 2. So 2 times 2 is breaking into new territory, 4. So then we have 4 here. Next iteration of inner loop, call becomes 3. So 2 times 3 is 6. It's not 3. And then now what for the outer loop? Row becomes 3 because we come back to the top. So then we can see that call goes from 1 to 3, and so we see 3 times 1, 3 times 2, and now 3 times 3. So in fact, we can have multiple nested loops like this. So if we have like a matrix of values or an array of values where you have rows and columns, kind of like the assignment 4, this would be a good way to print going across those. Okay, so let's go back into this. So yeah, the inner loop goes through all the iterations before the outer loop does one iteration. Yeah, inner loop complete their iterations faster. I don't know why it says this. This is straight from the publisher. Complete their iterations complete faster. I'm not sure why that's that way. But Maybe they used a nested for loop to print this. I don't know. The total number of iterations for the inner loop is the product of the number of iterations of the two loops. So what does that mean? So how many iterations will the inner loop execute no matter what? Just the inner one. 3. Per iteration of the outer one. Yeah, 3. How many iterations of the outer one are there? 3. Could, for example, I have this instead? Do I know exactly the number of times the inner loop will execute in this case? Well, now it depends on the value of row, right? If row was 2, then this inner one will execute only twice. But since we had 1 here, doesn't matter what the outer row was. The inner one's going to execute exactly 3 times. And the outer one executes exactly 3 times also. So in total, how many iterations are there? And it's not 6. It's 9 because it's 3 outer ones. And for each one of those, I do 3 inner ones. So yeah, when it says that the total number of iterations is just the product of the two, that's not necessarily true. It's true for this one. But if we have the inner loop depending on the outer loop in terms of the number of iterations, then this may be a little more complicated to figure out exactly. It's just convenient for this example because it actually is true. Okay, any questions about nested loops? Okay, so you may be wondering, when I talked about do while earlier, I said that it's not guaranteed that it'll actually go through the entire loop body. Break is the reason for this. So what did we use break for before? For the switch statement, to get out of one of the cases in the switch statement. Break can be used for loops as well. So break, if you put a break statement inside a loop, it'll break out of that loop. But let me ask you this. So suppose I did this. So if I put a break statement right here, what's going to happen when I reach this break statement? Well, as I said, it breaks out of its for loop. Which one? The inner one. So the for loop that it corresponds to. Now let me ask you this, because this might trip you up a little bit, but it's actually very interesting. So I'm going to put some condition right here, and then some code right here. What if I reach this break statement? What's going to happen? Well, it exits the if statement, but does it exit the for loop as well? Let's find out. Because it's actually very interesting. I say that a lot, but it really is interesting. So let's actually, come on, let me go. So let's just say our condition is if row plus call is at least 5. Just some random condition. Let's see. So let's say that, let's see out when this actually happens. And then let's actually, let's do something interesting. So let's put a bool right here to be false. And let's set it to be true in here. But I'm going to set it back to false right after the if statement. So let's just say that the break right here got out of the if statement but did not get out of the for loop. What's the value of b right here? So let's just say that you did encounter the break statement right here, but it broke only out of the if statement, but not out of the for loop. What should the value of b down here? it should be false. Because if it broke only out of the if statement, I set it back to false right here. But if it broke all the way out of the for loop, what should it have value? True. And we have an easy way to check for that. So if B, cout, broke out of loop, else broke only out of if. So it's rather complicated to see, to get this to actually work, but let's actually find out. Do I have an yes, I do. Need to format your code, I swear. Oh, that's interesting. I didn't expect that. It did both of them. That's I expected it to be broke out of the loop. Wait, hold on. So let's see. Okay. So let's see. Let's actually step through this because I did not expect that. Let's look at this. So it happened after the first iteration of the outer loop and all 3 iterations of the inner loop. Oh, okay. So this was the nature of the value 5 that I picked. If I run with 4, it'll never do it. So anyone can tell me why the 5 example didn't work? It did both of them? Yeah.
Because, was it because column was 4 for a second, and then went back to 2 for column?
Yeah, so let's think. It happened after these first 3. So what is the value of row on the first iteration of the outer loop? 1. What is the value of the call in the 3 iterations of the inner loop? 1, 2, and 3. Are any of those combinations with 1 or 1, 2, or 3 at least 5? No. So that's why the if statement actually didn't ever become true. Whereas if I put 4 here, it always is true at some point. There's 1 and 3, it'll work. So that's why the example worked here. So it really does break out of its corresponding loop. But think about this for a second. It breaks only out of its loop, but not the other loop either. So it breaks out of if statements, but and the corresponding for loop, but not the other for loop. So this is actually really useful sometimes when you're looping over something and you have these complicated if statements on the inside and you only want to break out of the loop itself, then this is a great technique to break all the way out. If it only broke out of if statements, then we need some additional stuff right here to check, did we just break out of the if statement or not? So it's nice that it breaks all the way out of the for loop. So this is just for you to think about. So break can be used with loops in addition to switch statements. It terminates the execution of a loop. So no matter what it's in, it breaks out of the next loop or switch, whatever the case may be. Use it sparingly. I use it all the time because the nature of what I do, but in normal code, it's very rarely used. It's just harder to understand because if you encounter this break, then you're breaking the structure of the loop that is looping over. So something might go wrong in that case. But if you can guarantee nothing will go wrong, this is a good solution because it ensures fewer iterations are executed. Yeah, it breaks only the inner loop, not the outer one. But another technique which I've used sometimes, and it's very handy when it is needed. So break, as we just saw, gets out of the loop entirely. But what if you want to have it be so that you don't want to execute the rest of the loop body, but you want to continue the loop anyway? So if you look at this, for example, so let's go back to what we had before all this mess. like this. Suppose that we had some if condition right here, some random if condition right here with stuff. Maybe like some condition is satisfied. I don't want to print this C out. So if this condition happens to be true, I don't want to print this C out, or if there's a bunch of code below. What I could do then is I can write the word continue. So what continue does is wherever it is in the for loop body, it skips the rest of the loop body and then comes back up to the top. So in this case, if we encountered this statement, this continue right here, it skips everything else, so it skips the C out, and it comes back up to where the update occurs. Okay, so it doesn't go all the way out of the loop. It just only goes, it skips the rest of the iteration. So if you have some condition that you don't, that is like a bad condition that you don't want something to happen, but you want to check the rest of all possible conditions anyway, then continue is a great option for that. So if like, for example, if row plus call is less than 3, for example, I don't want to print those ones. So if you want to print, say, a multiplication table, and you think, okay, the multiplication table with ones, I don't care about those. I only care when both of them are at least 2. So then, for example, you could say if row less than 2 or call less than 2, then I don't want to print the multiplication table for those. I don't care about those. But I do want to print if any one of them becomes, if both of them are at least 2. So if I encounter a condition I don't want, like this one, then I could say, I'm going to skip the rest, but I'm going to try the next iteration anyway. So that is what a continue is for. Yeah, so if you use it with a while or do while, it goes directly to the test condition and repeat if true. For loop, it goes to the update step. So effectively, they do the same thing. Again, it's just use it sparingly. Okay, any questions about loops or break or continue? Yeah.
I'm still having trouble with the continue.
Mhm.
Right? It seems incredibly redundant. Because if you're just going to skip over a bunch of code, why are you including it there?
Yeah, so it's just, so why would you even use continue? So continue is actually, you could avoid continue if you wanted to. So there's nothing special about the continue here. It's just to make it a lot easier. So I could say, do this, remove the continue, and put everything else in an else block like this. I could do that too. But then I have to re-indent all of this, and then I might have to refactor, and I might make a mistake. So if I just leave all the rest of the code alone and just put a continue there, I have no issue. So it just makes it a lot easier to read than to put a whole else block in there. Yeah.
What's the difference between Bool and Flag?
What's the difference between Bool and Flag? Can anyone tell me? There's actually no difference. So a flag, remember, is just a Boolean variable that you set to some initial value. Then if at some point later you may change that value, and then much later you'll check if the flag was actually set to true. So you may set it, okay, initially to false, and then at some point later, if something happens, you set it to true, and then all the way down at the end, if it was set to true, then you do stuff. Otherwise, you say, okay, you probably entered something invalid, or something like that. Other questions about loops? So nothing on the rest, on the test will cover anything from this second onward. So let's get on to, in the last few minutes, into something called functions. But before I do that, I want to come back here to the code about the nChooseK example we did. So I don't really care about the functionality of the code, but is there anything that seems a little odd or annoying to you about this code? Or redundant? Is there something that seems a little similar among these parts? It's about the same. Why do we do that? Why don't we just offload all of the important stuff and then keep the only thing that changes back in main? So would you rather write code like this or like this? So what's happening here? What's happening here is I'm offloading the factorial part to just one place. So if I need to change it, I only need to change it in one place. And then I'm just offloading all of the calls to factorial off to one place and doing the computation in one place. So then our main function is a lot shorter. Would you rather write this code? I hope you would, because if you need to make a change in one place right here, maybe like I screwed up and I put a less than right here on all of the conditions, wouldn't I have to change it in every place? Yeah. So by having it all in one place, it's a lot easier to manage. Now, could you write code like this? Do I need that function in the example over here? Do I need this? No. I could fall down and hit my head and write code like this if I wanted to. But would I want to? No. So functions don't give us any additional things we couldn't do before. So we could declare anarchy and say no to functions ever again, and put everything in the main function if we want to, if we were insane. But functions make everything easier. So the concept of functions is really something called modular programming. So the idea here is instead of having hundreds potentially of lines of code all in one place in like the main function, I'm going to break it up into multiple small chunks and then relate the chunks together. So like in the example I just showed you, I offloaded the factorial right here, the n choose k part right here, and main over here, and then I related them depending on whatever we needed to do. So modular programming is break up a program into smaller chunks and then relate and put them together. A function basically is just a module in modular programming. It's just one piece. Usually you're performing one task. So in the example I showed you, one function was solely there to compute the factorial. One function was solely there to compute n choose k. So they have one functionality that they need to do. Whereas before, in our main function, we had all of these tasks all in one place. So this function, the main function, was doing multiple things, but that's against the idea of modular programming. Make each function do one task and then relate the tasks together. So why would you want to do this? It simplifies the process of writing programs, because if you have this giant task that you need to solve and you can break it up into subtasks, then you can say, oh, I'm going to work on this one task and this task only, and not even think about the other ones. So then I can just write the function for just that task, and then once I'm done with that, now I can move on to the next one and then relate it to the one I just completed. So it simplifies the process of writing, because before I had to think, okay, which things should I do first? Which things should I do second? Because with functions, it doesn't matter which one you write first. If you can write all of them, that's all you need to do. And it improves maintainability, because if I have just a single task in one function, then I only need to change that one function and nowhere else in the code, because it's unique to that one task. So it's a lot easier to write code this way. Okay, how much time do I have? 27 seconds, perfect. So I promise this slide's the last one. So a function call is when you are calling a function. The definition is basically the parts of the function that the task is included with. So there are 4 things that are in a function: the name of the function, the parameters of the function, the statements in the function, and something called a return type. which we'll get to next time. So I'll see you all on Wednesday.